Today we will be talking about motion. Before we begin with the mathematical context of motion, we begin by interpreting motion by means of graph. There are four types of motion: linear motion, circular motion, projectile motion, and rotational motion. Now let's consider a distance time graph. As shown here in the figure is the distance time graph of an object which moves at a time frame from 0 seconds to 20 seconds. So what is interesting about the distance time graph is that it tells us something about the motion of the object. One thing that we need to consider here is knowing the slope of a distance time graph. If we recall, slope is actually the change in the y-axis over the change in the x-axis. In this case, we have the change in distance over the change in time. We have to remember that for a distance time graph, the slope actually represents the speed. Now let us investigate further what the graph tries to tell us. So if you see a graph leaning towards the right, what does it tell us about the motion of the object? It tells us that the object is gaining distance as the time progresses. And as it gains distance, it also acquires a certain quantity known as speed. Okay? So if the object's graph in a distance time graph is leaning towards the right, then our slope is a positive slope. So if our slope is a positive, if slope is positive, then speed is gained. Okay? Now, if we have a graph something like this, as you can see, as time progresses, the distance stays at 14 meters. It means that the object is not moving. Okay? So if the slope is parallel with the x-axis or with the axis of time, then the object is not moving. Now let us examine this part here where the slope is leaning to the left. If the slope is leaning to the left, it means to say that we are losing speed. Another way of saying this, another way of interpreting this graph is that the object is returning from its starting position. Okay? So that is what we can say for a distance time graph.